primitive or value data types versus reference data types. Maybe you have noticed this before. I have the same object inventory and then I log it several times. And between these logs, I have a change. In our case, I add one error. And from the first point of view, it seems that nothing strange. The first object values are 0, and in the second object, we see error equals to 1. But if I expand it, you will see something strange if you don't know what are reference data types. You see that our error is equal to 1. For understanding this problem, let's start from the primitive data types, which also calls value data types. Numbers, strings, boolean, undefined, and null are primitive data types. So they are stored somewhere in the memory, and when I create a new variable, for example, let n equal to 3, I allocate some memory for this variable n, and then I go to the pool of all primitive data types. Here I can find 3, and then I copy and paste it into the memory of the variable n, which has its own data cell in the memory with the duplicated data of 3. And now I declare the second variable m that is equal to n. So in this case, JavaScript tries to find the variable n. We see that we have this variable, then it looks to the data of this variable. Variable n contains a number, which is a primitive data type. And in this case, we allocate a new memory cell to the variable m. And then we copy and paste the value from the variable n. And now we have two different variables with duplicated data. So in the real memory on your computer, you have several cells with the value of 3. And this is a very straightforward and logical way how we create new variables. So each variable has its own memory with some data. What happens with reference data types? Arrays, objects, and functions have reference data types. For example, I want to create the variable t, which is an array of values 1, 2, and 3. And the beginning is absolutely the same as with primitive data types. And some difference I can see only when I want to create a new variable p, which is equal to t. So in this case, JavaScript tries to find the variable t, then it looks to the data type that this variable has. In our case, this is an array, which is a reference data type. So, and at this point, JavaScript doesn't allocate any new memory for this variable. And then we just put this variable in front of the previous variable. And it means that both these variables, p and t, share the same memory. I did the same steps in the code. So we have the variable t, which is an array of 1, 2, and 3. And then we have the variable p, which is equal to t. And now I log to the console both these variables. And at this point, we see that both these variables has the same data. So we have a feeling that p just cloned the data from t. But then I add a new element 4 only to the t array. And then I log to the console both these arrays again. And now we see that even though that I pushed only to one array t, both arrays have been changed. And this is because they share the same memory. If I really want to create a new array with the same values, I need to copy an entire array with all these values and paste them to the second variable. And in this case, we see that my push to array t affects only the t array. And if I expand logs, you can see that the first array, which is t array, contains 4 values, and the second array, which is p array, contains only 3 values. And now it means that they don't share any memory. Also, a small clarification why we see different data in the log if we expand it. When we create a new array and then log it to the console, here we see the snapshot of the current state of this array. And if I expand it, I see the actual state of this array. So the lastly changed state of this array. So I add a new element 4 to this array, and now I see two different snapshots of the same array. But if I expand them, they contain the same data because this data refers to the actual state of this array. Now let's do a small quiz to check your understanding of this topic. You can pause the video and think as much as you need. The first question is, which data type has null in JavaScript? Null is a primitive data type. So what about true? True is also a primitive data type. Now I will show you a small snippet of code and you need to answer, do these variables share any memory or not? These variables don't share any memory. The first variable is my variable, which contains the number of 22, and numbers are primitive data types, so it means that when the variable num is equal to my variable, we actually copy and paste the value of 22 into a new memory cell. And we also have a variable myArray, which is equal to an empty array. So this is a reference data type, but it doesn't share this array with other variables. So it means that we don't have any shared memory between these variables. Now what you can say about these variables? These variables also don't share any memory. All these variables contain reference data types. However, numbers contain an array and it doesn't share it with anyone. Object 1 and object 2 contain objects. Even though that the data is the same, they are allocated in different memory cells because we manually copied an entire object. And we can easily prove it by adding a new element to the object 1. So before my logs, I add a new property letter with the value of a to the object 1. And now in the console we see that object 1 contains two properties, number and letter. And if I expand it, we also see both these properties. And object 2 contains only one property, number. And when I expand it, you see only one property. These objects can share the same data, but it happens when I write that object 2 is equal to object 1. So here, instead of the data of the object 2, I type that this is equal to object 1, and now they share the same data. And in the console, you see that even though that I changed only the object 1, both these objects have a new property. Now we know the main difference between primitive data types and reference data types. In the next video, you will learn about classes in JavaScript